Hi, so today we're going to talk about a Rust command line interface tool that I made. This tool essentially allows one to do ETL and CRUD operations on a SQLite database. So this is the overall project architecture. We can start with any HTML link that has a table in it, and then pass it through the extract.rs function to load it to a CSV file, and then pass that CSV file to a transform underscore load script. This basically transforms the column names and then the data types, adds data types information and everything, and loads that data to a SQLite database. We have three other functions called query, update, and drop data. These also take custom inputs, and then, for example, you could pass it a custom query to query the database, likewise a custom query to update the database or drop data. One cool thing about Rust programs is once you have it compiled, you can actually release the code in terms of a binary, and then anyone can download the binary and then run the code. For us, this binary would be available in the GitHub Actions tab. So build and package Rust binary. You could just go in there and then go to the bottom of the page and download this binary. I'll show you in a bit on how to run this binary. While we're here, we can also see that the other workflow runs, such as lint, test, and format, is also running. This can also be seen in the README file by clicking on these badges. So let's dive right into the demo, starting with the main file. We can see that we use the clap library to make our main file into a command line interface. All of these interface, for example, mode, short name, long name, help, okay, takes value. That means like it needs a value if this is called. Contrary to just transform tags, which just tells you like when this tag is involved, we just want to do the transform operation, so no value is required. These are just some default values, and then this is actually how, based on the arguments, we're running the different functionalities. For example, if the extract tag is present in the inputs, we're going to run the extract functionality, and then as a result from the extract function that's located in the extract module, we get either okay or an error. This is a cool part about Rust as well. It has a type called result, which if it's okay is going to give you back the okay type along with anything else you want to return. But otherwise it's going to return an error, and that's going to be signified by E. We can handle this error in many different ways, but for now, since this is mostly for a demo purpose, as of now, we're just printing out the error. But for each different type of error, we could see how we can handle the error differently using if-else statements. Let's go into one of the functions, extract, for example. A lot of this code was written using GitHub Copilot. The original version of this was in Python. So I think this is also a perfect example of how one could prototype in Python and then port over to more complex languages that are more efficient and utilize less resources using Copilot. So I use Copilot like prompting to generate a lot of this code and help me debug a lot of this code, especially the tests. All of the tests were completely solely written by Copilot. I just gave it this function and asked it to generate tests for it. So this bit tag essentially tells Rust that this is a test function. So whenever I run a make test, which is defined as cargo test, it goes into all of these files and runs the test portion of it. The main file does not have any test, of course. Another cool functionality, let me see if I can find it, is this enum data type that's unique to Rust. So for example, this query function, when I'm testing it, it takes an in-memory database connection. And when I'm running it, it takes a database name. The enum data structure allows us to accept two or any other number of types of connections that we want. So for example, we have database in connection. We say that the connection type can either be a string or it can also be an in-memory connection from the SQLite package itself. And we can see how they're handled differently based on the type they are, which is very cool. This question mark is how we propagate errors to the main file. We could have handled the errors here as well, but I preferred to keep it simple and propagated it over to the main file. And then similarly, we have update test file here as well, and then transform, nothing too interesting. So yeah, when we do cargo build and then release, with the release option, it creates a binary file, test Python, which I moved over outside. And then let's see how that works. So I already have it loaded. So as we can see, this is the binary that was made when we released it. And it takes a custom query, and then we tell them that this is the database that we want to connect to. Running that gives us the first 4 rows of these columns. Let's make another change here. Let's now actually use the cargo run functionality. So running it using a binary is one way, but we can also run it using cargo run. It's just a little more verbose, nothing wrong with it. But if you're developing, this is a good way to run it, versus if you're distributing, the binary is a better way to run it. Of course, much easier than some other programming languages such as Python. So let's just run a quick update process. We're just gonna make these categories into 0, where player is Steven Adams. Says update successful, very fast. Faster than Python from what I've checked. And then just to see if the update went through, yes, it did. Yes, it did. So all of these categories are now 0. So yeah, I spoke about how GitHub Copilot is very, very, very useful in programming in more complex languages like Rust, and how it can be used to take a project from a prototype phase to the production phase. If you have any questions, please refer to the README file about dependencies. It has example usages as well. I hope you enjoy this project. Thank you.